members have been joined. So remaining people will join later. Right? So today will be the continuous classes about our last class, right? So last class we have discussed about metering schedules, right? How actually once we just installed a meter in company, and how actually we are just getting a data and how we are just going to store the data, right? So because nowadays we'll have an advanced meter, not like a traditional meter, right? So every data should be stored in what could I say in a storage devices like hard disk. Definitely, we need to after 5 to 10 years, definitely we need to upgrade our system, right? Because we are not having enough space to store all the data, right? Definitely, as per company requirement and company management or organization based goal, right? So energy goal. Based upon that, only the meter should be send the data to particular storing device, right? Like storing computer. So last class we had discussed about the boiler unit, right? So I'm just going to give you that one more small input, right? So here I will have boiler, right? So we are actually we are using four types of energy: coal energy for firewood chops, right? Or maybe coal or firewood. We'll have a steam output. We'll have a steam. We need definitely we need a water energy, and we are just going to use theoretical motors, right, for a chimney, a forced draft or induced draft fan, right? So definitely electricity energy also used. So for that purpose, definitely we are using sub metering over those applications, right? So we're actually that meters, right? So that meter data energy or measuring data. So whenever the chimney pathina 24 hours 360 phase run ஆக chimney like a fan, right? So only more now actually the threshold level, right? So smoke அதிகமா form ஆயிடுச்சு furnace குள்ள, then only that chimney fan is going to be getting turned on, right? By automatically there is a one more sensor is now going to be attached with my furnace inside furnace, right? It's going to detect my gas smokes, right? So if it's crossed that particular level, definitely the chimney fan is automatically it's getting turned on. So the chimney fan la it will be around 20 HP, 40 HP, right? It will be very higher than the top those things, right? அப்போ அந்த மீட்டர் பார்த்தீங்கன்னா 24 hours டேட்டாவை சென்ட் பண்ணி என்னுடைய கம்ப்யூட்டிங் சிஸ்டத்தில் ஸ்டோர் பண்ண தேவையில்லை. So whenever the chimney fan is going to be turned on, that duration only we are just going to store the data, right? That's what a metering schedule. So there is no universal definition. I already told that there is no universal definition for smart metering, right? As well as the schedule. You could follow your own strategy, which is based on your company goal, right? So company goal எப்படி fix பண்ணுங்க, electricity energy reduce பண்ணணும்னு நினைக்கிறீங்களா, இல்ல if you're just going to think water flow consumption reduce பண்ணணும்னு நினைக்கிறீங்களா, இல்ல wastages we're just going to recover back, right, by using reverse osmosis RO plant install பண்ணிட்டு RO plant வந்துட்டு reverse water which is going to apply reverse osmosis, and then you can get more usable water from a wastewater treatment வந்து பண்ண முடியுமா? So by doing this only they want, so by just going with that these some of new ideas, then you could easily make our own metering schedule, right? There is no universal format. That's why these are the things we have already started, and today we are just going to see about flow meters, right? So I already told that how that meter is going to be what could I say communicated to our competing devices, right? So flow meter already we have started, but I'm not actually we didn't finish about that working principle and operations, right? So energy meter already we have very well known that, right? So flow meter where it's going to go. Flow meter itself we could able to measure the steam flow, fluid, right? What kind of flow, either water இருந்தாலும் சரி, இல்ல diesel இருந்தாலும் சரி, petrol, whatever may be the fluid, right? Steam right? So you could able to measure those fluids, right? Definitely that method of operation we need to know. So anyway, I'm just going to go with that different kind of different technology we just be using to measure the fluids, right? So we'll see a different within 15 to 10 minutes, 10 to 15 minutes we'll just consider, and then just going to come into economic analysis, right? Now I'm just going to share one more tab. So before into that, anyone just came across real life? Just anyone came across any flow meters for measuring your fluids, right? Anyone just heard or maybe you have seen any flow meters in our real day-to-day life? யாராவது பார்த்துருக்கீங்களா? Anyone? Yes, anyone? யாராவது சொல்லுங்க, பார்த்துருக்கீங்களா? டே டு டைப்ல எங்கேயாவது ஃப்ளூயிட் மெஷர் பண்ற மீட்டர்ஸ் பார்த்துருக்கீங்களா? யா, anyone? எஸ் ப்ளீஸ்.
சார் ஃப்ளூயிட் மெஷர்.
ஃப்ளூயிட் மெஷர்மெண்ட் மீட்டர் எதை பார்த்துருக்கீங்களா?
சார் லைக் நான் வந்துட்டு pH மெஷர் பண்ற மீட்டர் தான் சார்.
ஓகே ஓகே. இன் டே டு டே லைஃப்ல எங்க பார்த்துருக்கீங்க? எங்க சினிமாஸ் பார்த்துருக்கீங்க pH மெஷர் பண்ணுறது?
சார் pH மெஷர் வந்துட்டு இங்க இது போர் இதுக்காக போகும்போது வந்துட்டு.
ஓ, அந்த ட்ரிங்கபிள் வாட்டரா இல்ல ஆசிட்?
ஆமா சார், அதுக்கு தான் சார் ஆர்ஓ ஃபிட் பண்றதுக்காக போகும்போது
பார்த்துருக்கேன். எஸ் கண்டிப்பா கண்டிப்பா. வீட்லயே இப்ப நியூ டைப் ஆஃப் ஆர்ஓக்கு பிளான் பண்ணிட்டு இருக்காங்க. ஸோ அவங்களும் அந்த மாதிரி டிவைஸ்ல எடுத்துட்டு வருவாங்க. ஸோ எடுத்து வந்துட்டு உங்க வீட்டில் ஆர்ஓ பிளான்ட் இன்ஸ்டால் பண்ணிட்டு இந்த ட்ரிங்கபிள் வாட்டர்ல தேர் ஜஸ்ட் கோயிங் டு அட்ஜஸ்ட் செட்டிங், ஆக்சுவலி செட்டிங் போயிடுவாங்க. ஓகே. தென் வேற ஏதாவது ஃப்ளோ மீட்டர் பார்த்துருக்கீங்களா? எனியும் வேற ஏதாவது? பட் பீப்புள் ஆர் ரெகுலர்லி யூ ஆர் ஜஸ்ட் சீன் பட் couldn't able to remember. அதான் yes, is it? Yeah, exactly. Who is that? JP. Yes, exactly right answer, right? That's what I'm also having that example, right? So petrol pump you are just using a fuel, right? So அங்க யூஸ் பண்றது பியூர்லி ஃப்ளோ மீட்டர். ஸோ அங்க இருக்கிற கம்பெனில போய் பாருங்க, அந்த மிஷின் இருக்கு இல்லையா, தட்ஸ் ஜஸ்ட் கோ அண்ட் சம். இதுக்கப்புறம் நீங்க போனீங்கன்னா போய் பாருங்க, ரைட்? ஸோ அந்த கம்பெனி அந்த டீட்டெயில் எல்லாம் எழுதிருப்பாங்க, நேம் பிளேட் டீடைல்ஸ் இருக்கு இல்லையா, அதை செக் பண்ணுங்க, இது என்ன கம்பெனி மேனுஃபேக்சர் பண்ணிருக்காங்க. ஸோ இன்னும் கொஞ்சம் கீழே டீடைல்ஸ் தான் பார்த்தீங்கன்னா என்ன டைப் ஆஃப் மீட்டர்ஸ் யூஸ் பண்றாங்க. ஸோ ஒரு சில ப்ராடக்ட்ல நோட்டிஃபை பண்ணியிருப்பாங்க, ஒரு சில பெட்ரோல் பங்க்ல நோட்டிஃபை பண்ணிருக்க மாட்டாங்க, ரைட்? ஸோ ஐ ஜஸ்ட் சீன் இந்தியன் ஆயில் பங்க், அதில் இங்கே சங்கையில் நான் பார்ப்பேன், ரைட்? ஸோ தே ஜஸ்ட் மென்ஷன் this type of flow meter we are just using. So they are using about vortex, right? So நிறைய type of meter இருக்கு. So they are just using this type of flow meter, right? So many of the people use with magnetic flow meter, right? So magnetic, we'll see different types of flow meter because we're just going to pay money, right? So for that fuel, so we need to cross verify that. So now 200 rupee 300 rupee na electricity, sorry, what could I say, fuel fill பண்ணனும்னா I need to verify with that. So now how actually I'm just spending money, right? That was most important thing, right? So anyway, I'm just going to share one small video. So this is a overall collection about or whole about your what could I say, fluid meter measurement, right? So we'll have different types of technology. So if people crossed this technology, it will be very well known. So because we people belongs to AAA, that's why every principle which is behind that flow meter, it will be very basic, as well as you people already crossed. But you may not aware of that, right? So இதுதான் யூஸ் பண்ணாலும் நமக்கு தெரிஞ்சிருக்காது. We'll see, right?
Word.
So this is the first one, right? So we'll see, this is my normal mechanical meter. So here before playing this video, just go with this website realpass.com, or maybe they are also having one more YouTube channel also, realpass. So this is common what could I say, field instrument. These devices are called field instrument, right? So these are some measuring devices, but it has its own, why it's called instrument and sensor. So there is a flow sensor சொல்லலாம், but industry people they will call it as transmitters அப்படி சொல்லுவாங்க. Transmitters இன்னும் கொஞ்சம் தெளிவா சொல்லணும்னா field instruments சொல்லுவாங்க, because these peoples are directly installed or played a major role in a directly field, right? So controllers will be located on my control station, but these peoples are located on my field area. That's why it's called field instruments. Why it's called instruments? ஏன் சென்சார்னு சொல்ல மாட்டேங்கிறோம்? Sensor is nothing but it's a physical what could I say, mechanical devices. It's directly responding, its physical changes நடந்துச்சுன்னா that sensor part is going to be physically, it's now responding. But this changes is happening, right? Physical parameters, and the physical parameters are nothing but temperature, pressure, flow, level, right? So these are the things. This is called physical parameters. Other than நம்ம measure பண்றோம், other than we are just going to controlling, right? So in the fluid, this is called my inlet pipe and outlet pipe, right? Here we are having 4 types: mechanical, magnetic, vortex, and ultrasonic. So these are the different types of technology we are using to measure a simple fluid flow, right? Flow of fluid. So for example, mechanical என்ன பண்ணிருப்பாங்கன்னா, they are just going to install the propeller, right? Like propeller safe blades, right? So blade இங்க கனெக்ட் பண்ணிடுவாங்க. எவ்வளவு blade போகுதோ, சரி எவ்வளவு what could I say, how much fluid is now moving. So அதுக்கு ஏத்த velocity speed வச்சு என்ன ஆகும்னா, the blade is now getting rotated. So based upon this rotation, definitely my meter is now getting turned on. It's look like our bike meter reading, right? So the same thing. But in a magnetic meter, we'll say it's not somewhat important. So many industries, right? Many oil and gas industries, petrol, not a gas industry, water, just in our textile industries. Many industries, right? So water measurement, water flow measure பண்றதுக்கு, a steam measure பண்றதுக்கு, they are using magnetic type of flow meter, right? So it's quite cost will be very high. But anyway, so once we just install, don't need to bother about your flow of energies. Everything is now calculated in the form of digital. Once it's just digital calculate பண்ணிட்டு, you could able to wirelessly communicate பண்ணிக்கலாம், wirelessly communicate பண்ணிக்கலாம். So vortex and ultrasonic. We'll see one by one, so a little fast on a போயிடுறேன். And these are the sum of meters, right? Now, why we are just moving in this direction? But actually, we are just moving in electricity energy. But அதை நம்ம நிறைய டிஸ்கஸ் பண்ணிட்டோம். அதனால எனர்ஜி மீட்டர் நான் மறுபடியும் பேசல, அந்த மீட்டரிங் ஷெட்யூல் மறுபடியும் நாங்கள் போல. ஸோ we'll have different types of energy flow. That is all. இண்டஸ்ட்ரியில் பார்த்தீங்கன்னா 5 types of energy காமனாக யூஸ் பண்ணுறாங்க: electricity and water and diesel, right? So we'll have steam, air, compressed air. But now I'm just only focused on fluid, right? Water fluid. We'll have இதே மாதிரி நீங்க வேற மீட்டருக்கும் படிக்கலாம், பட் இட்ஸ் நாட் அப் டு டைரக்ட் டு திஸ் டாபிக், ரைட்? ஒன்லி மீட்டரிங் ஷெட்யூல் மட்டும் தான் சொல்லணும். பட் நான் அதை வெறும் தியரியா சொன்னா உங்களுக்கு புரியாது. தட்ஸ் வை ஐம் ஜஸ்ட் கோயிங் டு கோ வித் சம் physical parameter measurement and with some of the sensors. Then only it will be easy to understood, right? That's it.
Button and subscribe. The measured liquid must be water-based or conductive. This makes the mag meter a great choice for wastewater or processed water that is considered fouled or dirty. Mag meters are volumetric meters that have no moving parts. This is ideal for those areas.
Actually, it will be very easiest concept, right? So actually, we are having two types of magnet, that's called electromagnet, north pole and south pole, right? We are just going to pass the electric current on over this electromagnetic coil, as well as here also. Definitely, there is a constant magnetic field is going to be set on this area, right? So this is what my pipeline, right? So anyway, I'm just going to show you that the real magnetic. You could able to create your own homemade magnetic flow meter. இப்போ ஃப்ரீ டைம்ல தான் இருக்கீங்க வீட்டில், ஸோ you could able to create your own magnetic flow meter in your home itself. Just try பண்ணி பாருங்க. So this entire area is going to cover it. But in horizontally, I'm just going to fix this two electrodes actually, right? Two electrodes. Simple principle is that electromagnetic induction principle, Faraday's law, right? So here, Faraday's law is now used over here, right? It will be very familiar theorem in our EEE department, right? So electric AC induction motor, right? So the same principle here also it can be applicable, right? So basic principle it will be that one. No issue, right? Already people aware of those theorems very well, right? And actually, so நம்ம மோட்டரில் மட்டும்தான் மேக்னெட்டிக் இண்டக்ஷன்ல ஃபேரடே யூஸ் பண்ணிருக்கோம்னு நினைக்கிறோம். அப்படி கிடையாது. The same principle it can be applicable for different applications, right? Here that are same principle, the same what could it say theorem, it's now applicable for to measuring fluid, right? So that's what a different thing. We'll see. For example, if there is no fluid, right? So if there is no flow of fluid inside pipe, right? So we'll see there is a constant flux lines is now will be there at this area, right? If any fluid is now flowing, like a water or a diesel or petrol or maybe steam, so fluid always a good conducting medium, right? So electrically good conducting medium. Whenever the fluid is now getting started to moving from this direction, definitely, right? So already there is a magnetic flux lines is will be available, but now conducting fluid is now coming, right? அப்ப என்ன ஆகும்? Definitely அதுலயே electrons இருக்கு, right? So அதுலயே fluidsலயே electrons இருக்கு. Here we are passing external magnetic field lines. Definitely due to this field lines, right? So definitely the fluid is now getting the electrons is now getting the atoms, right? So what water molecule may be or maybe conducting mediums, right? So the molecule is getting vibrated. So due to this, there is a EMF is now getting induced on my to these electrodes, right? So I'm fixing two electrodes on both ends. So anode and cathode. Definitely there is a EMF is going to be getting generated. That's called potential difference is going to be generated, right? that potential difference, that is called voltage, is now generated on my this two end of this electrode. So which is now directly proportional to this fluid flow. So எவ்வளவு fluid போகுதோ அதுக்கேற்ற மாதிரி voltage generate ஆகும், right? That's what then based upon this fluid velocity, right, we could able to directly calculate my current, that is called voltage, right? Voltage is now directly proportional to fluid flow. When fluid flow கிடைச்சிச்சுன்னா directly we couldn't able to measure fluid flow, that velocity, right? So that velocity is in the form of we are just calculating voltage. Voltage is now representing my this fluid flow speed. So speed கிடைச்சிருச்சு. In the area we already have a mechanical area, right? Only it's not going to be changed anymore while manufacturing itself the same area. That area is now multiplied with my this fluid flow rate. Then it could easily measure this fluid flow rate, right? Volumetric rate. So this is a simple principle, right? We'll see.
Where you wouldn't want to be exposed to the measured liquid while working on the meter. The way a mag meter works is based on a formula called Faraday's formula. Firstly, again, the liquid must be conductive. A voltage is measured that is dependent on the average velocity of liquid times the strength of the magnetic field times the length of the conductor. This is the distance between the electrodes. This is all that wonderful science stuff. You know, like E equals mc squared. It's Einstein's theory of relativity. We've all heard of or seen the equation. Many of us don't know what it means. However, the people that do know how to use the equation have used it for both benefit and detriment. For example, the atomic bomb. We don't need to know Faraday
So this
like
is one more
E
thing,
equals
right?
mc squared.
So actually, Albert Einstein just what could I say? Already told that. So we already will familiar with the Faraday's law. So we electrical people only we are thinking like that, right? So we are just thinking about electrical motors, transformers, right? Power system, power electronics. We are just thinking like that, right? So the same thing. Einstein is talking about E is equal to mc squared, space and time, right? So that's the special related theory. Space and time much or பேசிட்டு போயிட்டாரு. But this fellow, right? So this man, what he just I couldn't
However, the people
anyway.
that do know how to use the equation
This man, Julius Robert Oppenheimer, right? So he just thinking that E is equal to mc square formula, which is driven by what could I say, Einstein. That formula, he just thinking, he just applied in a different area. Then he just find atom bomb, right?
have used it for both benefit and detriment. For example,
So our special relativity he just created, right? But the same principle which is will be also available on atom bomb, right? And the energy will be delivered, right? That much. The same thing, right? So here we'll have a Faraday's law. The same principle we could able to use in a flow meter also, right? So electrical motor lane, transformer lane, we are just using the same principle we could use in a different area. That's why it's one more application is coming back that is called a magnetic flow meter. That's why we need to think in such a way that we need to use that formula where it could be applicable. Wider we need to think it, right? Then only we could have a wider option, right? That's why.
this formula to use a mag meter. We don't necessarily even need to know what that formula is. We just know that whomever invented the mag meter used the formula to produce a signal voltage that can be measured by your automation process. While mag
Here, once you just measured the flow rate in the form of a voltage, right? This is a voltage signal which is now generated by this transmitter. I already told that this is called a field instrument. Simply, we'll call it as a flow transmitter. That is called, everything is now called a field instrument. On the field instrument, this is called my magnetic flow meter, which is going to measure this flow inside the fluid, inside the fluid pipe, right? So that's why it's called FT. FT in the sense of flow transmitter. Sometimes we're just going to measure some pressure in this tube, in the sense they will call it as PT, pressure transmitter, right? Sometimes we're just going to use TT in the sense temperature transmitter. So why it's called actually transmitter? Why not called it's transducer? Why not it's called a sensor? Why they actually called transmitter? Right? So common industry people they will call it as this is called a transmitter. Why it's called transmitter in the sense this whole system consists of, here will be a sensor will be applicable. I will just show you, right? So the here will be sensors will be applicable. Here inside there is a microcontroller that's called microcontroller, and A to D, D to A display, and communication port, right? So this all entire thing is now covered in this single system, right? That's why it's called transmitter. Transducer only will have a sensor and signal conditioning circuit, but இங்க பாத்தீங்கன்னா onboard microcontroller, battery backup, and communication port, sensor, signal conditioning circuit, A to D, D to D, எல்லாமே இருக்கு. That's why it's called a transmitter, right? So this signal, which is now commonly it will be 0 to 12 volt or 0 to 5 volt output, right? Based upon manufacturer 0 to 12 volt, right? It's continuous or digital data. This signal which is now sent to my PLC, that's called field controller over here. It's going to measure, it's going to get a data from this flow, what they say, from this transmitter, and it's going to directly, it's getting only voltage, and we are having a programming over in my PLC, and it's going to have a better decision on this flow rate. So if you're just going to measure the flow rate, then only you could able to control the flow rate, right? So then only you will have a control valve over here, and you could able to control the flow rate into the pipe, right? So in such a way that you could able to maintain your level in our tank, or maybe pressure in our tank, right? Whatever we could do. So this is called entire what would I say, factory automation, right? So for the purpose, definitely. So in the meter continuous data measure பண்ணிட்டே இருக்க போகுது, but in our point, so metering schedule, right? Flow எப்ப இருக்கும் அப்ப மட்டும் data, it's getting stored on my storing devices. But anyway, data is continuously 24 hours is getting measured, right? Measured and monitored and controlled, but that metering data should be stored in some particular schedule, right? So நம்ம fluid இருந்தா மட்டும் ஸ்டோர் பண்ணிக்கலாம், டேட்டாவை ஸ்டோர் பண்ணலாம். Otherwise it's going to only dynamic process running at it. We are not going to store this data in the time level flow போச்சு டேட்டாவை ஸ்டோர் பண்ண தேவையில்லை, flow இருந்தா மட்டும் ஸ்டோர் பண்ணா போதும். That's what metering schedule, right?
Meters work based on Faraday's formula. Other flow meters work in different ways.
This is what called one more mechanical flow meter before invention of a magnetic flow meter, vortex flow meter, right? So this is what my one more mechanical meter. So we'll have a rotary blade will be installed inside this tube, and whenever the fluid is coming, the blade is now getting rotated. Based upon this rotation, we're having gear arrangement, and we'll have a what could I say, metering and thing to be there.
For instance, a mechanical flow meter has some moving internal parts which may not fit with specific applications, such as dirty water that carries large particles that may cause damage or obstruct the internal parts.
So anyway, I'm just going to pause it over here, and we'll see, because we are just running out of time. That's why I'm just going to show you one more flow meter that is called, it's going to use a different technique, right? It's going to use one more different technique. I'm just going to moving into one more slide. That is called differential pressure transmitter, right? It's also going to measure your fluid flow rate, right?
The most diverse substance.
So differential pressure flow measuring principle. So already we have crossed our 12th standard, right? So where we just crossed about Bernoulli theorem, Venturi, right? So these are the thing, right? So one more physicist, right? So the எல்லா டெக்னிக்குமே around ஒரு 200 years 300 yearsக்கு முன்னாடியே கண்டுபிடிச்சது. Still we are not aware of that, because we are not focused on those things also. Only we have studied many things and we didn't apply it anywhere. That's why we got a bigger issue, right? So whatever we just studied, we need to apply it in practically, then only we just able to find out new things, as well as we could have better understood about what actually we are just studying. We could able to have a clear idea once we just applied in practically only, right? So இதெல்லாம் நீங்க ரொம்ப ஓல்ட் டெக்னிக், நம்ம 12th ஸ்டாண்டர்ட்லயே படிச்சோம், but we just forgot it actually. So concept படிச்சோம், but concept படிக்கிறதோட நிறுத்திக்க கூடாது. We need to apply it in practically, at least in our laboratory itself, or maybe a home itself. Then only we just able to understand what actually. So once understood பண்ணிட்டீங்கன்னா, we could able to have our own creativity. We could just able to get new one. That's why it will be very easy. We'll see one small animation that is called one more differential. The name itself has the meaning, differential pressure, right? We're just going to create a difference pressure, right? So we'll see.
The most diverse substances are transported and distributed. Fluids flowing through pipes often have principle. Some
So always this differential pressure transmitter always it will be in this position. So it look like a hanging position. So நீங்க மத்த டிரான்ஸ்மிட்டர்லாம் பாத்தீங்கன்னா மவுண்டிங்கா இருக்கும், மேல மவுண்டிங்கா இருக்கும். TT or PT or MT, that's called a flow meter FT. But in the differential transmitter மட்டும் கீழே ஹேங்கிங் இருக்கும். So நீங்க ஒரு இண்டஸ்ட்ரிக்கு போனீங்கன்னா ஐவி போனீங்கன்னா definitely just to see wherever you could see this green this yellow sorry blue right sorry. So wherever you just see blue color mounting this type of shapes, in the sense wherever just see in a longer area, definitely you could assume that there is a flow meter, there is a transmitter, right? There is a transmitter அப்படிங்கிற மைண்ட்ல நீங்க ஃபிக்ஸ் பண்ணிக்கலாம். ஸோ நீங்க நியர்பை போனீங்கன்னா you could have the name plate details, அந்த நேம் பிளேட் டீடைலே காமிச்சிருப்பாங்க என்ன டிரான்ஸ்மிட்டர் டைப்னு சொல்லியிருப்பாங்க, right? So but wherever you see அந்த fluid pipeல அங்கங்க பாத்தீங்கன்னா டியூப் அந்த மாதிரி இருக்கும். That's why it's called a transmitter. So we'll see what actually we are just doing in the sense, right? So difference pressure நம்ம create பண்ண போறோம். அந்த pressure by through pressure only we are just going to create a voltage difference. So இது எப்படின்னு பார்க்கலாம். Here this is called oncoming fluid will be coming here, right? So this is outgoing. So inside என்ன பண்ண போறேன், பைப் கட் பண்ணிட்டு we are just going to create one more small disc, open disc தான், ஒரு வாசர் மாதிரி, right? வாசர் மாதிரி we are just going to create it. So வாசர் நான் உள்ள ஃபிக்ஸ் பண்ணிட்டேன். வாசர் இந்த டயாக்கு ஏற்ற மாதிரி வாசர் மாதிரி ஒரு that called o-ring, right? So வாசர் o-ring. So அந்த மாதிரி ஃபிக்ஸ் பண்ணிட்டேன். So fluid வந்ததுன்னா அந்த o-ringல ஹிட் ஆயிட்டு again it's coming. So அப்ப என்ன ஆகும், there is a turbulence is going to be getting created, right? So அந்த pressure தான் we are going to convert. So அந்த o-ring that's called வாசருக்கு முன்னாடி ஒரு டியூப் எடுக்கிறேன், வாசருக்கு ஆஃப்டர் ஒரு டியூப் எடுக்கிறேன். ஸோ இதுலயும் ப்ரெஷர் இருக்கும், இதுலயும் ப்ரெஷர் இருக்கும். பட் இந்த ஏரியாவுக்கு ரைட், இந்த டியூபோட ஏரியாவோட நான் ஃபிக்ஸ் பண்ற ஏரியா ஆஃப் அந்த o-ring வாசர் இட் பி வெரி லிட்டில் பிட் இட் வில் பி ஸ்மால், ரைட்? ஸோ இட்ஸ் நாட் எக்ஸாக்ட்லி திட் மச் டயா, அதோட கொஞ்சம் கம்மியா இருக்கும். அப்படிங்கிறப்ப கண்டிப்பா இங்க ப்ரெஷர் அதிகமா இருக்கும். ரிலீஸ் ஆயிட்டு அந்த o-ring அப்புறம் ஒரு ப்ரெஷர் கம்மியா இருக்கும், ரைட்? பிகாஸ் ஆஃப் திஸ் ரேஷியோ நம்ம ரிடக்ஷன் பண்ணிட்டேன், ரைட்? இந்த டியூப்ல ரேஷியோ அதிகமா இருக்கும், ப்ரெஷர் அதிகமா இருக்கும். இந்த செகண்ட் அவுட்புட்ல இருந்து வர ப்ரெஷர் கம்மியா இருக்கும். ஸோ இன் பிட்வீன் நம்ம என்ன பண்ண போறோம், ஐம் கோயிங் டு யூஸ் த டயாஃப்ராம். ஸோ இந்த ப்ரெஷர் அதிகமா இருக்கும். whenever the fluid is now much high ஸ்பீட்ல வந்துச்சுன்னா இந்த பக்கம் ப்ரெஷர் அதிகமா புஷ் பண்ணும். அப்ப இந்த டயாஃப்ராம் இட்ஸ் now moving this direction. If the flow is now coming, the diaphragm it will be in the same position. Whenever the pressure is getting increased, in the sense definitely there is a fluid is oncoming fluid will be very high. So அப்ப pressure அதிகமா என்ன ரீசன், டெஃபினட்டா fluid அதிகமா இருக்கு. அப்ப இங்க டயாஃப்ராம் வந்துட்டு மூவ்மெண்ட்டே இல்ல அப்படின்னு அர்த்தம், fluid வந்து ரொம்ப ஸ்லோவா தான் வந்துட்டு இருக்கு. So definitely you could able to measure the pressure with the help of diaphragm. அந்த diaphragm movement நடக்கும். அந்த diaphragm movement என்ன பண்ணிருப்பேன், I'm just going to connect it with potentiometer. அப்ப diaphragm front and back நகர்ந்துச்சுன்னா potentiometer front and back நகரும், வோல்டேஜ் எனக்கு கிடைச்சிடும், ரைட்? ஸோ அந்த வோல்டேஜ் தான் we are just going to measure in the form of fluid rate. We'll see.
100 years ago, Swiss mathematician and physicist Daniel
So
Bernoulli,
Bernoulli, right? So you
discovered
already
the
you people heard about this scientist named Bernoulli, right?
direct relationship between the pressure and speed of a fluid flowing in a pipe. Italian physicist Giovanni Battista Venturi also built the first. Here is how this measurement method works. Differential pressure flow meters have an artificial restriction integrated into the measuring tube, illustrated
This
here.
one, right? So this is a small o-ring, right? So o-ring or maybe a disc type, a washer type metal. I'm just going to install it, right? So அப்ப fluid வந்ததுன்னா என்ன ஆகும், இந்த ஹாலோ இந்த டியூபோட சைஸ் அதிகம், இந்த வாசர் சைஸ் கம்மி, ரைட்? ஸோ இப்போ fluid பாத்தீங்கன்னா இவ்வளவு தூரம் வந்துட்டு இதுலயே தான் வெளியில போய் ஆகும், ரைட்? அப்ப இங்க ஒரு டியூப் ஃபிக்ஸ் பண்றேன், ஓரிங்குக்கு அடுத்து ஒரு டியூப் ஃபிக்ஸ் பண்றேன். அப்ப இங்க ப்ரெஷர் எப்படி இருக்கு, இங்க ப்ரெஷர் எப்படி இருக்கு. ஸோ இதை மெஷர் பண்ணி தான் I'm just going to creating a pressure difference, right?
Here by the example of an orifice plate. Two holes are located in the pipe wall, one
These two
before
holes,
and
right?
one after the orifice plate.
Before holes,
Two separate tubes connect these holes to a differential pressure sensor with its two pressure chambers, separated by a diaphragm. The tiniest pressure differences in the flowing fluid can be precisely measured. If the fluid is not flowing, the pressure before and after the orifice plate is
so if there is no fluid is there, right? So if there is no flow, fluid is here, in the sense there is no pressure, right? There is no pressure. The same way you could easily call it as pressure from before this plate tube and after this plate tube, it will be same pressure. So the diaphragm is not going to be moving front and back, right? left to right, the diaphragm is not going to moving. Anyway, there is no voltage is now getting generated. So that there is no fluid. If the fluid is now coming, definitely based upon the fluid velocity, speed, right? Definitely my pressure is it will be getting changing. Due to that, right? So definitely my diaphragm is now moving, right? Definitely, if your diaphragm is moving, there is a voltage is going to be generated.
Essentially identical. As soon as the fluid starts to flow,
This is the right. You people already just you have tried in our school days, right? So சின்ன டியூப் வச்சு நீங்க விளையாண்டு இருப்பீங்க. The same thing, right? So same childhood daysல நம்ம ப்ளே பண்ணதான். இங்க பாருங்க fluid இந்த டியூப் ஃபுல்லா வந்துட்டு இருக்கு. We are having a disc type or if it's a plate, right? So அப்ப என்ன ஆகும்? Fluid definitely இந்த ஹோல்ல தான் ட்ரை பண்ண போகும், right? அப்ப என்ன ஆகும்? The fluid is now it's now what would I say? It's now the pressure, right? So it's try to move in this small hole, but the tube is this much. அப்ப என்ன பண்ற? We are having fixing two holes over here also here after two hole. அப்ப இந்த fluid என்ன ஆகும்? இந்த இடத்துல accumulate ஆகும், பயங்கரமா accumulate ஆகும். Then pressure is going to be built up. So இந்த இடத்துல artificial இருந்து வெளியில போறப்ப it will be going much speed, but pressure will be very less. But here in the accumulated area, pressure will be very high.
its velocity around the orifice plate increases significantly because of the restriction in the cross-section. At the same time, due to the laws of fluid mechanics, the static pressure at this point decreases. Consequently, different values are detected in the pressure chambers of the sensor, a higher pressure before and a lower pressure after the orifice plate. This pressure
That's why இங்க pressure அதிகமா இருக்கும், இங்க வரப்ப pressure கம்மியாயிடும், but velocity அதிகமா இருக்கும், but pressure இங்க அதிகமாயிடும், இங்க கம்மியாயிடும், right? That's the importance, right? Based upon this pressure measurement, you could able to indirectly measure every fluid speed, right? Flow rate. So எல்லாமே small technique தான், but in the differential pressure transmitter ஓட price என்ன தெரியுமா? 30,000 40,000 வரும் in industry, right? For example, yearly ஒரு 1000 ப்ராடக்ட் நீங்க செல் பண்ணீங்கன்னா for ஒரு manufacturing company in the sense, right? For example, which imagine பண்ணி பாருங்க, your company turnover, so around 500 to 600 companies it will be available, right? Flow meter mesh, what could you say, manufacturing companies around the world, right? It's a very bigger market in automation industry. Flow meter measurements, temperature measurement, right? We'll have a number of manufacturing company, including Honeywell, Robert Bosch, Siemens, and ABB. Many companies are just generating this type of meters, right? Flow meters.
is a direct.
So this is a main thing, right? Now we'll have one more one more technology, right? So that is called by using ultrasonic waves, right? So anyway, I'm not going to play much that video. I'm just going to only give you about the technology which we are just in, which they are just involved, right? I'm not going skip an error because we need to move different topic, right? So there's one more technique by using ultrasonic, right? So we'll see.
Moving in the same direction, ultrasonic
right? So
transmitters.
Here this is a Siemens based company, Siemens based flow meter measurement. So this is the tube, right? This is the pipeline. The inside pipeline, the fluid is going to be moving. So we'll have two types of sensors, right? One is an ultrasonic sensor and receiver, right? So we'll have a sending end, we'll have a receiving end. So the same way we are having in opposite directionally, right? So fluid is, for example, fluid is going in this direction in the sense. So I'm just going to sending a signal. So when I send the signal, fluid or directionally இருந்துச்சுன்னா receiving time period it will be very less. For example, fluid இல்லாதப்போ, right? So it will take about 1 second instance. For example, I'm just telling for understanding purpose, it will be very microsecond la போகும், இல்ல millisecond la போடும், right? Due to the distance. So நான் sending and receiving signal receiver time period will be 1 second, for example. At the same way, one more cross in the opposite la fix பண்ணிருக்கேன், right? So in this direction, for example, if the fluid is coming in this direction, in the sense, this is called downstream. So இதுக்கு ஆப்போசிட்ல இருக்கிறது upstream, downstream, upstream. So downstream ஏரியால இருக்கிற ஒரு பொசிஷன்ல ஒரு சென்சர் வைக்கிறேன், இன்னொரு upstreamல ஒரு சென்சர் கிராஸ் மார்க்ல வைக்கிறேன். இங்க ஒரு டிரான்ஸ்மிட்டர், இங்க ஒரு இங்க ஒரு டிரான்ஸ்சீவர், இங்க ஒரு ரிசீவர் வைக்கிறேன், ரைட்? ஸோ இப்போ if there is no fluid in the sense, இந்த upstreamல போறதும் சரி, downstreamல போறதும் சரி, ரிசீவிங் எண்டுக்கு ரிசீவ் ஆகிற டைம் பீரியட் ஒரு செகண்ட் தான் இருக்கும். For example, fluid is now moving in this direction, left to right, right? இப்போ பாத்தீங்கன்னா the fluid is now moving in this direction. I'm sending the signal, right? So here and downstream send பண்றேன், upstream இங்கே send பண்றேன். And downstream because the signal is now that is called ultrasonic signal, microwave. That microwave, it has its own particle. Definitely the fluid is going like this. அப்ப என்ன ஆகும், இந்த signals இது push பண்ணி இழுத்துட்டு போயிட்டே இருக்கும். அப்ப எனக்கு receiving time பார்த்தீங்கன்னா it will be very very less, around 0.5 second. For example, I'm telling 0.5 second reach ஆயிடுச்சு வச்சுக்கோங்களேன். It told that, right? Definitely okay, the fluid is now flowing அப்படிங்கிற data we could able to calculate. The same way upstreamல பாத்தீங்கன்னா 1 secondல fluid இல்லாத போனப்ப இப்ப நான் 1.5 second எடுத்துக்கும் because of upstreamல signal pass ஆயிட்டு இருக்கு. Then there is a huge difference is now getting created, right? So upstream and downstream. So either base பண்ணி என்ன பண்ணலாம், we could able to find out flow rate. This is one more technique.
And receivers are placed opposite each other. Ultrasonic waves are alternately sent and received by means of the piezoelectric effect, where mechanical energy is converted into electrical energy through the use of a crystal. When moving in the same direction as the flow, they travel faster than waves traveling.
I already told that. So if the fluid is now moving in this direction in the sense, right? So it will be very fast, right? Without the flow, it will be very low.
Against the direction of the flow.
So with the flow பாத்தீங்கன்னா the right, so நான் signal வந்துட்டு pass பண்றேன், flow rate இப்படி போயிட்டு இருக்கு. So எனக்கு 20 secondல reach ஆயிடுச்சு, but against the signal pass பண்ண it will take 50 milliseconds, right? It will be much difference. So by having this time period calculation, definitely you could able to calculate the flow rate. If the speed of a flow rate, it will be very high in the sense, and against the flow fix பண்ற speed, it will be very high, right? So you could got the concept, right? This is what different technology to measure your what could you say, flow rate. So ray flow rate will have different technology, mechanical gear arrangement, magnetic energy, ultrasonic, differential pressure, and then we'll have one more thing, vortex meter. But anyway, I'm just going to moving with vortex, but it will be very one more important meter. So இது இவ்வளவு மீட்டர்ஸ் இருக்கு, இவ்வளவு மீட்டர்ஸ் இண்டஸ்ட்ரியில ஃபிக்ஸ் பண்ணிட்டு ஒரு கான்செப்டுக்கு இவ்வளவு மீட்டர்ஸ் இருக்கு. will have டெம்பரேச்சர் இருக்கு, and pressure இருக்கு, லெவல் இருக்கு, we'll have steam, we'll have diesel, we'll have electrical energy. So இவ்வளவு மீட்டர்ஸ் நம்ம இண்டஸ்ட்ரியில ஃபிக்ஸ் பண்றோம், ரைட்? இன் பர்டிகுலர் பாயிண்ட்ல ஃபிக்ஸ் பண்ண மாட்டோம், எவ்ரி நோடு, ரைட்? ஸோ என்னென்ன ஏரியாவில் நம்ம ஃபிக்ஸ், எவ்ரி டிபார்ட்மெண்ட்ல நம்ம மீட்டர்ஸ் ஃபிக்ஸ் பண்ண போறோம். இந்த டேட்டா கண்டினியூஸா கண்ட்ரோலர் கூட கம்யூனிகேட் ஆகும், பட் ஸ்டோரிங் மட்டும், ஸ்டோரிங், ரைட்? ஸோ ஷெடியூலிங் ஆஃப் ஸ்டோரிங், that will be based upon ஒரு எனர்ஜி மேனேஜ்மெண்ட் கோல், ரைட்? கம்பெனியோட கோல் என்ன ஃபிக்ஸ் பண்ணிக்கலாம், அதுக்கு ஏற்ற மாதிரி ஸ்டோர் பண்ணிக்கலாம், ரைட்? So this is something about metering and metering schedule, right? Meters schedule. Now we'll go into, we are not having not that much time. Now we are just going moving into next topic, that is called economic analysis, right? Which actually I just planned for today class, but it will be half an hour late already. Now I'm just going to moving into today topic. Last class I discussed on the continuously 20 minutes, and today we are just going to see about which is new topic, economic analysis, right? What actually economic analysis now, right? I think my screen is getting shared actually. I think you could see my screen. Yeah. Now we are just going to see about next topic, economic analysis. Economic analysis is nothing but it's how actually we are just starting company, what basis we have started, and how much money we have invested, right? So purchasing of equipment and building, civil construction, electrical connection, right? So we're just having a number of investment onto that company. Definitely we need to get a profit, and we need to utilize the resources, right? Electrical energy நம்ம யூஸ் பண்றோம், and water energy யூஸ் பண்றோம், generator யூஸ் பண்றோம், electrical energy generate பண்றதுக்காக we are consuming diesel energy, and we are using transport, we are using human manpower, அவங்களுக்கு salary கொடுக்கணும், right? We are having a number of energy we need to use, right? Actually to run a company. So அப்படிங்கிறப்ப we need to get a profit from that organization. Definitely that profit should be very high at the rate, as well as time consumption கம்மியா இருக்கணும், profit அதிகமா இருக்கணும். Utilization of resources should be very important, right? So electricity energy waste பண்ணக்கூடாது, we need to what could I say, optimize பண்ணி யூஸ் பண்ணணும். So these are the thing we need to consider. So that's why it's called economic analysis, right? So இது எப்படி பண்றாங்கன்னு பார்க்கலாம், right? And this is a previous class which is just included slide, metering option and scheduling, right? Submetering, these are the things we have just discussed, metering, schedule, and example, right? Today we are going to see one more example. Direct economic analysis generally பேசினா புரியாது இல்லையா? Direct economic analysis சொன்னா maximum it will be getting bored, right? That's why I just go with that one type of a small example. So if you're just going to create, if you're just going to install a small hydro power plant in our home or maybe a small village, right? If you're having installed a small hydro power plant, and how we could able to calculate economic analysis on my that small hydro power, right? So அதை எப்படி பண்ண முடியும் அப்படிங்கிற analysis we can just could see. Okay, definitely hydro plant install பண்ணனும்னா what are the things we definitely we need to consider? Definitely electrical energy we just producing. அப்படிங்கிறப்ப எனக்கு கண்டிப்பா ஆல்டர்னேட்டிவ் வேணும், டர்பைன் வேணும். ஸோ ப்ரெஷரை பில்டு பண்றதுக்கு we need a reservoir. ரிசர்வாயர்ல வந்துட்டு வாட்டர் கொண்டு வரணும்னா I need பென் ஸ்டோக்ல வந்துட்டு டர்பைன்ல ஹிட் பண்ணணும். டர்பைன் வந்துட்டு ஜென்ரேட்டர்ல கனெக்ட் ஆகணும் ஆல்டர்னேட்டர்ல. I need a voltage regulator, I need a grid connection, I need a power backup, I need a output, right? So இவ்வளோ these are the things we need to build up. So அப்படிங்கிறப்ப we need to invest money, right? So civil construction for a building construction பண்றதுக்கு civil construction we needed, and equipment purchase பண்ணணும், piping and instrumentation diagram, P&I diagram சொல்லுவாங்க, right? Piping and instrumentation. So எல்லாமே sensors fix பண்ணணும், meters calibrate பண்ணணும். So we are just going to purchase many meters, many pipelines, many instruments, many devices, many controllers, right? We need to install and purchase and install, and we need to doing erection commissioning work. So எல்லாத்துக்கும் we need to invest more money. So invest பண்ணியாச்சு, building கட்டியாச்சு, everything we just purchased it, right? Finally, what is the profit from the hydro power plant? Definitely we are just generating electricity energy and we are just exporting to utility grid, and we are just getting paid from that consumer, right? So other than that, we are just going with the analysis, right? We'll see. So now economic analysis is now based upon two things, right? So it will be demonstrating about economic merits behind a project, right? And optimal utilization of resources. I already told that. So by doing an economic analysis, you could have that better understanding about your utility resources, right? So நம்ம electricity energy use பண்ற industry and water energy and steam energy, in the resources you could have better awareness, and you could able to use your resources in such a way that you could able to increase your profit as well as you could able to reduce your wastages by doing economic analysis. See, and this is a graphical representation. There is a project which is running by year, and we're just going to focus on EIRR, that is called economic internal rate of return. That is called pay. Simply we call it as, namely we will already call it as payback period, right? Payback. So அது வந்துட்டு return basisல சொல்லுவாங்க. We'll see. And this is a unacceptable range, right? So payback ரொம்ப கம்மியா இருக்கு அப்படின்னா year increase ஆக payback ரொம்ப கம்மியா இருக்குன்னா that's called unacceptable range. This is a marginal quotient range, acceptable range, right? We'll see. And what are the tools will be available, right? So இதுக்கெல்லாம் டூல்ஸ்லாம் இருக்கு, எக்கனாமிக் படிச்சீங்கன்னா தெரியும். But I am not also much strong in economy. I'm not economist, right? So I am just a teacher, right? Professor maybe, right? So this is some standard economic tools will be available to do analysis, right? It's called some audit, right? So every company there is an auditor will be there. That person is now responsible for doing this analysis, right? Anyway, which is going to have a simple idea over that, right? For example, if you're having small hydro power plant, that is lifespan about 70 years, but not exactly 70 years. 50 years we're just able to run it, right? 50 years நம்ம ரன் பண்ண முடியும். அப்போ 50 இயர்ஸ்க்கு what is the profit? எப்போ பேபேக் ஸ்டார்ட் ஆகும்? ஸோ அந்த கால்குலேஷன்லாம் நம்ம பண்ணணும் இல்லையா? ஒரு மணி வச்சிருக்கேன், ஒரு பவர் பிளான்ட் நான் கிரியேட் பண்ண போறேன்னா we need to raise a question, right? So எனக்கு எப்போ பேபேக் ஸ்டார்ட் ஆகும், எவ்வளவு மணி நான் ஏர்ன் பண்ண முடியும், நான் 2 crore ஸ்பெண்ட் பண்றேன்னா 2 crore எனக்கு எப்போ எனக்கு ரிட்டர்ன் பேசிஸ்ல எனக்கு ப்ராஃபிட்டா கிடைக்கும், right? These are the questions will be rising, right? In the businessman mind, right? So we need to thinking like that, right? So for example, for that purpose we need to have a time frame. I already told that project நான் வந்துட்டு 2 crore போட்டு நான் கம்பெனி ஸ்டார்ட் பண்றேன்னா அந்த கம்பெனி எவ்வளவு நாள் நான் ரன் பண்ண முடியும் அப்படிங்கிற கொஸ்டின் இஸ் இட் ரைஸ் ஒரு கொஸ்டின். அண்ட் இன்ட்ரெஸ்ட் ரேட் எனக்கு எப்போ வரும், கேபிட்டல் நிறைய இன்வெஸ்ட் பண்ணிட்டேன், தென் வேர் இட் இஸ் ஆக்சுவலி இன்ட்ரெஸ்ட் ரேட் ஃபார் தட் 50 years நான் என் கம்பெனி ரன் பண்றேன். ஃபார் எக்ஸாம்பிள் SHP, ரைட், ஸ்மால் ஹைட்ரோ பவர் பிளான்ட். ஸோ 50 years ரன் ஆகுதுன்னா எனக்கு 50 yearsக்கு என்ன எனக்கு இன்ட்ரெஸ்ட் கிடைக்கும் அப்படிங்கிற டேட்டா. ஃபார் எக்ஸாம்பிள் 2 crores இன்வெஸ்ட் பண்றேன்னா 50 yearsக்கு என்ன இன்ட்ரெஸ்ட் ரேட், and discount rate and discount cash flow, These are the things we need to consider, right? We people already only know these two things: time frame, எவ்வளவு years நான் run பண்ண முடியும், and the small hydro power plant. அதுக்கு மேல definitely alternator change பண்ணணும், because due to number of operating hours and years, definitely aging ஆயிடும், அந்த machine replace பண்ணணும் totally. And turbine, penstock, everything we need to replace, right? Because that's why it's called lifespan. And the interest rate, நான் 2 crores spend பண்றேன்னா எனக்கு 50 இயர்ஸ்க்கு எனக்கு இன்ட்ரெஸ்ட் ரேட் என்ன வரும், இது மட்டும் தான் நமக்கு தெரியும். And in last 3 and 4, discount rate and discounted flow cash, right? We'll see. So discount rate is the determinant of feasibility, where actually interest rate is usable, right? That's called, we'll see, feasibility. Discount rate will have different type rate, right? And discounted cash flow, right? It is actually using to, what could I say, particular period kapro. I'm not going to, for example, 50 years in a time frame irukuna, after 10 years I'm not going to invest much more money, adukapra invest panna maten, only I need to get a payback. So on the edathula discounted cash flow is now getting started, right? And total project parameters about my small hydro power plant, enna thevapodum, right? So enna things we need to consider: installed capacity we need to focus, annual energy production evlo varudhu, load factor enadhu, capital cost evlo, operating and maintenance cost evlo, expected na evlo interest rate edirpaakalam for about my installed thing, and discount rate eppadi irukum, construction period eppo mudinjadhu, finance period eppo start panna poran, values of energy. And these are the things we need to consider about much important parameters we need to consider about in any type of project, right? It will be common to a small hydro power plant, right? And this is a small picture which I'm going to show you, right? Which I got it from internet, right? So this is a small thing. So behind that hill there will be a reservoir, and there is a water. You could see, where I could see in industry green color, it will be a shows that water line, and that's called penstock, and we are having a turbine, and we'll have a alternator in this one, and trail gauge, right? So this small hydro power plant, right? So for a small village, right? And what are the methodology will be available to analyze on economic? It's called economic analysis. We'll have two types of method: static method and dynamic method. So we people already aware of the payback method only. So, but other methods we'll see. I'm also just a little bit confused, right? So method right? We'll see you just what could I say, economic, because if you're a economist, we are just a teacher, engineering teacher. We just know about engineering technique. But as an economist only, he knows just what are the different methods will be analyzing about our money. Our company aramikirana, so we are investing much money on that company. So definitely that businessman is just going to thinking about my profit எவ்வளவு வரும், எந்த இயர்ல வரும், எவ்வளவு, இந்த கொஸ்டின்ஸ் ரைஸ் அதிகமா இருக்கும். தென் அந்த மாதிரி கொஸ்டினுக்குலாம் ஆன்சர் பண்றதுக்கு ஆடிட்டர் மட்டும்தான், ரைட்? ஸோ பட் ஆஸ் அ பிளான்ட் engineer, like electrical engineer, right? So electrical manager, right? Electrical manager, or maybe a energy management in a particular company, he also should know the basic things about economic analysis also. That's why this topic also will be available in this area, right? Economic analysis is now basic two types: static methods and dynamic methods. So already we people discussed about payback period, right? So ஒரு மீட்டர் ஒரு energy flow meter வந்துட்டு இண்டஸ்ட்ரியில ஃபிக்ஸ் பண்றேன் அப்படின்னா, definitely I need to invest some money onto purchasing that particular meter. Then if definitely if I'm just purchased, right? So that's also called investment, right? So definitely as a businessman, I'm just going to raise a question. So if what is the payback period will be, right? அப்படிங்கிற question வரும். So இதெல்லாம் already we have discussed, right, in our previous classes. But now second thing, statically second method is now return on investment method. We'll see what actually return on investment method. And dynamic methods will have three types. ஸோ இதெல்லாம் நம்ம கேள்விப்பட்டிருக்க மாட்டோம், ரைட்? நெட் ப்ரெசென்ட் வேல்யூ மெத்தட், ஏன்னா எல்லாமே தெரியும், பட் இங்க செக்ரிகேட் பண்ணி வச்சிருக்காங்க. பெனிஃபிட் காஸ்ட் ரேஷியோ, இன்டர்னல் ரேட் ஆஃப் ரிட்டர்ன் மெத்தட், these things called dynamic methods. So static methods, what is the difference between my static method and dynamic method, right? In static method, we couldn't able to find out actually that in between opportunities. So company would upgradation, right? Smart and the hydro power plant வச்சு பேசணும்னா small what could I say changes நம்ம மேக் பண்ணுவோம். ஒரு 5 இயர்ஸ்க்கு அப்புறம் பார்த்தீங்கன்னா நியூ ஒரு AVR இன்ஸ்டால் பண்ணுவோம், ஆட்டோமேட்டிக் வோல்டேஜ் ரெகுலேட்டர். வில் சி we are going to upgrading something. ஸோ அதெல்லாம் நம்ம இதில் கண்டுபிடிக்க முடியாது. right? In dynamic methods, we could able to find out new opportunities, updating your system. We'll see one by one. So simple payback method, these are some academic analysis, right? So academic model, we'll see forthcoming classes, right? So before into that, we're just going to see about academic analysis. First method, static method, that's called simple payback method. So payback pathina investment develop பண்ணிருக்கீங்க. Total investment divided by total net annual revenue, right? So in the ratio தான் we're just going to call it as payback period. For example, நான் 2 crore spend பண்ணிருக்கேன். எனக்கு annual பாத்தீங்கன்னா 1 yearக்கு 5 lakhs தான் எனக்கு சார் 50 lakhs தான் என்னோட ரெவன்யூ வருது. ஸோ அப்போ how many years it will do? So per yearக்கு 50 lakhs only, right? So 1 year totally, right? இப்போ எனக்கு 2 crore ரீச் ஆகுதுன்னா எனக்கு மினிமம் 4 year ஆகும், right? 4 yearsக்கு அப்புறம் தான் எனக்கு payback period ஸ்டார்ட் ஆகும். This is a simple thing, right? This is the calculation. So payback is nothing but it determines the number of years required to earn more money, right? So apart, what we say above my investment cost. 2 crore மேல வந்தாதான் நான் 4 years ஆயிடுச்சு. 4 year என்ன பண்ண போறேன்? I'm just going to invest பண்ண காசு நான் எடுத்துட்டு இருக்கேன். So 4 yearsக்கு அப்புறம் தான் 4.1 month, right? அந்த மந்த்ல இருந்து தான் I just expecting my what could you say interest rate as well as my profit as well as my income, right? So அந்த 4 year I'm just only getting my investment cost மட்டும் தான் எடுத்துட்டு இருக்கேன். 4 yearsக்கு மேல அதுக்கு மேல எனக்கு profit plus income எல்லாமே வர ஆரம்பிச்சு. That's why it's called payback. In the form of they just called it as number of years, right? That is called a recovery or a break even period, right? So it's just a simple different name, different term. That's all. That's why it's called this name. And payback return. So what are the advantages about payback as well as disadvantage? So advantage in payback method, you could easily what could I say? Easily could identify the feasibility of project. Profit வரும் அப்படிங்கறது ஈஸியா நீங்க டிடெக்ட் பண்ண முடியும். And what are the disadvantages அப்படின்னு பாத்தீங்கன்னா, right? So it will neglect the opportunity cost. I already told that. So we couldn't able to find out what are the new upgrades and the opportunities to be introduced to get more money. So அப்படிங்கறத we couldn't able to predict, right? And then moving with that second static method, that is called return on investment. So the return on investment in the sense, so that is called simply they will call it as ROI analysis. It's going to calculate average annual profit, right, to my investment cost. So right, so it's going to calculate average annual cost, right, and net of yearly cost. That is called net of yearly cost in the sense it's simply called as a depreciation. Depreciation, it indicates that how much just you are utilized your resources, right? So எவ்வளவு நீங்க resources யூஸ் பண்ணிருக்கீங்க அப்படிங்கறத which is called yearly cost, right? That is a simple calculation that is called net annual revenue minus my industry resource நான் எந்த அளவுக்கு நான் யூட்டிலைஸ் பண்ணிருக்கேன், right? So அந்த ratio divided by total investment into multiplied by 100. This will give you about return on investment. Just got an idea. நான் இன்வெஸ்ட்மெண்ட் பண்ணிருக்கேன், அந்த இன்வெஸ்ட்மெண்ட் எனக்கு எப்ப திருப்பி கிடைக்கும், right? This is called return on investment. So இது வந்து pay back, right, period. Payback period நம்ம கால்குலேட் பண்ணுவோம். பட் இது வந்துட்டு how much I could able to get it, right? So how much money I could able to get it. So அதுங்கிறது return on investment, right? Just in the it's just going to calculate in the form of percentages, right? This is what a simple formula to calculate about this method. This is straight line method, right? So could able to find out that's why it's called return on investment, right? Depreciation எப்படி இண்டஸ்ட்ரியில கால்குலேட் பண்ண முடியும்னா total cost and salvage value, right? So by operation life. For example, நான் ஒரு டர்பைன் பிளேட் வாங்குற அப்படின்னா டர்பைன் பிளேடோட ஆப்ரேஷன் லைஃப் எவ்வளோ, அதை எவ்வளோ பர்ச்சேஸ் பண்ணேன், ஸோ அது ஆவரேஜா எப்படி வேல்யூ இருக்கும். That's why. So what are the disadvantages and advantages? It is simple net profit நீங்க percentage calculate பண்ண முடியும். And what are the disadvantages, right? Definitely this ROI method uses income data rather than money, right? So நான் எவ்வளவு மணி எவ்வளவு இன்வெஸ்ட் பண்ணிட்டு டைரக்டா எவ்வளவு மணி நான் வந்துட்டு இன்வெஸ்ட் பண்ணிட்டு எவ்வளவு மணி வரப்போகுது அந்த கேஷ் ஃப்ளோ டைரக்ட்லி ப்ரெடிக்ட் பண்ண முடியாது. பட் we're just going to get a percentage wise, right? Percentage wise we could able to find. And we'll see dynamic methods, right? Dynamic economic analysis we'll see forthcoming classes, right? Static method next stop பண்ணிக்கலாம். And we'll see a dynamic analysis on my forthcoming classes, right? So up to this just crossing anyway, dynamic methods we'll see before coming class, right? So any doubt up to this, we'll see forthcoming class, right? So anyway, we'll just be having one more class in the fourth class in the group. That's why I'm just going to pass it over here and we'll continue, right? Forthcoming classes. Thank you all and thank you all for listening. We'll meet by tomorrow, right?